Hello everybody, Mac here, and we are now going to talk about subtracting rational expressions, which basically is like doing fractions, okay? This is version A, and again, you can always go to maxtutorials.com, which is listed right down here, and you can find me there. And I explain a little bit how to do them, but sometimes it's better just see me go problem by problem. Now, I've done an addition one. This one's going to go by pretty quick, and the reason why it's going to go by pretty quick is if you notice, all the denominators are the same on this page. So we're just showing you that when you do this, when you subtract, what's 3x minus 1x? It's just a 2x, and you copy the denominator. Remember, when you're adding and subtraction fractions, all you do is you copy down the denominator. So if I go to this next one, 5a minus 1a is a 4a. Now watch. Do you see any pluses or minuses? No, I don't either. So we can go ahead and reduce. 4 goes in there once, 4 goes in there twice, and I get an a over 2. Okay? Here we go. Let's do the next one. All right, so when I subtract the top, I'm going to get a 4y over 7. Nothing can reduce. I'm done. Number 4, 7m minus 1n. Well, that's a 6m over 12. And when we reduce, that's just going to be an m over 2. Okay? Let's go on to number 5. If you get an 8n minus 5n, you get a 3n over 9. And when we reduce, we just get an n over 3. Okay, going on to number 6, 10p minus 3p, that's going to be a 7p over 11. Nothing to reduce there. This next one, I have 5x squareds. I'm going to take away one of those x squareds. I'm going to be left with 4x squareds over 4. No plus or minuses, so these can reduce. And my answer is just a simple x squared. Okay, going on to number 8. 7y squared minus 2y squared. Well, that's just going to be a 5y squared. That's over 10. And when we reduce, I'm just going to get a y squared over 2. Okay, going on. 8a minus 2a, there's a 6a squared over 12. And when we reduce, we're just going to get an a squared over 2. Okay? Going on here, again, nice and simple. Denominators are the same. We love same denominators. Okay, 8 minus 3 is going to be a 5m over 7. Can't reduce. Just a reminder, you can do this, but whenever we have a bigger minus a smaller, we can just go back to how we've always done subtraction and just do it. Okay, but there's going to be a point where we're going to have to really focus on these. Okay, and I'll show you that's going to happen in the next one. So this isn't one of those where you're just going to go ahead and go, well, I'm just going to do this once and we're going to be good. You want to go on to B and you want to go on to C on this one. All right, can I cross out those X's? The answer is no, because this X is attached to that plus sign. And remember, if you have a plus or a minus sign, those aren't factors. Those are terms. You can cross out factors. You can't cross out terms. All right? Now, here's why we're doing subtraction as a separate one than addition. Here's the part people mess up. So watch me. Okay, so we have the same denominators. Cool, all right? But now watch what I got to do. I got to treat this like an entire parentheses. Add it. In fact, I'm going to take the parentheses out just because it's going to get really busy. I'll zoom up. Add a line, but you got to change the sign of both. Change all the signs. Okay, so don't just change the one that's in front. Change both of them. So now I get a 2x minus x is x. And now I get a positive 3 and a positive 1. That's going to be a plus 4 over x minus 2. All right? Can I reduce the x's? Are the 2 and the 4? Nope, because of the plus and minus signs. Okay, they're not factors. They're terms. Okay, same thing here. Add a line. Change both of the signs. All right, 3x minus 1x is a 2x. Positive 2 plus positive 4 is a positive 6. Over an x plus 3. Done, right? Nothing more I can do? Well, take a look at this. Look at the very top. Always see if you can factor more. Here, I can pull out a 2. I'm going to be left with an x plus 3. Now look at this. If it's an entire term, I can cross that out. So boom, boom. I can't do an x and I can't do a 3, but I can do an x plus 3. And my answer is just going to be 2 here. All right? Let's keep going. 16, add a line, change all the signs on the right. 4x and a plus of minus 1x is going to be 3x. And I get a 1 plus 2, which is 3. Plus 3 over x minus 1. Now, I do want to pull this out, but you're going to notice there's going to be nothing I can do about it. That's just going to be the final answer, okay? Let's go on to number 17. Add a line, change everything on top. Now, only change the top. Don't change the bottom, okay? Because we're changing the sign, and just like anything, if I have 3/4 and I want to change the sign, I can change the 3, or go away. There we go. Or I can change the 4, or I can just write it out here in front, okay? But if I were to do this, change the top and change the bottom, well, what's the negative 3 divided by negative 4? It's positive 3/4. Well, that's where we started. So that's why we only changed the top, okay? You technically could change the bottom, but why would you? You want common denominators. 5x plus a negative x, that's like a negative 1x, right? So it's 4x. Positive 3, positive 1, that's a plus 4 over x plus 4. Now, I do want to pull out whenever I can do that. So, boom, I can do the what's the same, what's left over. And now I get that as an answer. Okay, 18, last one. Add a line, change both of the signs. Now, I'm going to get a 6x plus a negative 1x. That's going to be a 5x. And here, a positive 5 plus a negative 1 is going to be a positive 4 over an x minus 2. And done. All right? Well, there's A. That's a great start. But remember, where these get tricky is when we don't have common denominators. So we want to make sure you guys can do those as well. So I'll see you on B, and let's work on different denominators. See you there.